Friends, welcome in our own teacher channel. Class 9th, Subject Science, Workshop of Lesson number 3, Current Electricity. Question 1. The accompanying figure shows some electrical appliances connected in a circuit in a house. Answer the following questions. A. By which method are the appliances connected? The appliances connected in parallel connections. B. What must be the potential difference across individual appliances? The potential difference across individual appliances must be same as the supply voltage. C. Will the current passing through each appliance be the same? Justify your answer. No. Current is equal to voltage upon resistance. Even if the voltage is the same, the resistance can be different. Hence, the current through each appliance may not be the same. D. Why are the domestic appliances connected in this way? Even if one of the appliances is out of order, other appliance can be used. E. If the TV stops working, will the other appliances also stop working? Explain your answer. Even if the TV stops working, other appliances will not stop working as they are connected in parallel across the supply. Question 2. The following figure shows the symbols for components used in the accompanying electrical circuit. Place them at proper places and complete the circuit. Which law can you prove with the help of the above circuit? Ohm's law can be verified with the help of the above circuit. The direction of the electron current is from the negative terminal to the positive terminal of the cell. The conventional direction of the current is from the positive terminal to the negative terminal of the cell. The total current is distributed as I1 and I2. The positive terminal of an ammeter is connected to the positive terminal and the negative terminal of the ammeter is connected to the negative terminal of the cell. The ammeter and the voltmeter must have proper ranges for the measurement of current and potential difference. Question 3. Umesh has two bulbs having a resistance of 15 ohm and 13 ohm. He wants to connect them in a circuit, but if we connect them one at a time, the filament gets burned. Answer the following. A. Which method should he use to connect the bulbs? He should use parallel combination to connect the bulbs. B. What are the characteristics of this way of connecting the bulbs depending on the answer of A above? 1. The potential difference across all resistors is the same. 2. This arrangement is used to reduce the resistance in a circuit. 3. The total current flowing through the circuit is the sum of the currents flowing through individual resistors. C. What will be the effective resistance in the above circuit? The effective resistance in the above circuit will be 1 upon resistance of power is equal to 1 upon resistance 1 plus 1 upon resistance 2. Here resistance 1 is 15 ohm and resistance 2 is 30 ohm. So we will do here cross multiplication. 15 plus 30 divided by 15 into 30. So 45 upon 450. After dividation we will get 1 upon 10 means resistance of power is 10 ohm. Hence the effective resistance of the above circuit will be 10 ohm. Question 4. The following table shows current in amperes and potential differences in volts. 1. Find the average resistance. Resistance 1 is equal to V1 upon I1, 4 upon 9. We will get answer near about 0.44 ohm. Resistance 2 is equal to V2 upon I2 means 5 upon 11.25. We will get near about answer 0.44 ohm. Resistance 3 is equal to V3 upon I3, 6 upon 13.5. We will get near about answer 0.44 ohm. So the average resistance is 0.44 ohm. 2. What will be the nature of the graph between the current and potential difference? The graph between the current and potential difference will be a straight line. 3. Which law will the graph prove? Explain the law. The graph will prove Ohm's law, which states that if the physical state of a conductor remains constant, the current flowing through it is directly proportional to the potential difference between its two ends. Potential difference is equal to current into resistance. Question 5. Match the pairs. Directly answers are given. 1. Free electrons. Answer is C. Weakly attached. 2. Current. Answer is A. V upon R. 3. Resistivity. Answer is D. VA upon Li. 4. Resistance in series. Answer is B. Increases the resistance in the circuit. Question 6. The resistance of a conductor of length X is R if its area of cross section is A. What is its resistivity? What is its unit? Resistance of a conductor is small r, length of a conductor is small x, area of cross section is small a. Resistivity of conductor is given. Density is equal to Ra upon L. Now R means resistance is given small r, A means area of cross section is given small a, and L means length of conductor is given small x. Now we will put that value. So density is equal to Ra upon x. Unit of resistivity is a ohm meter. Question 7. Resistances R1, R2, R3 and R4 are connected as shown in the figure. S1 and S2 are two keys. Discuss the current flowing in the circuit in the following cases. 1. Both S1 and S2 are closed. In this case, total current of the circuit will flow through branch FG and branch HI will not conduct any current. Hence, the current will flow only through resistances R1, R2 and R3 and it will not flow through R4. 2. Both S1 and S2 are open. In this case, current will flow through resistances R1, R3 and R4. However, since the branch DE is open, it will not flow through R2. 3. S1 is closed but S2 is open. In this case, current will flow through resistances R1, R2, R3 and R4. Question 8. Three resistances X1, X2 and X3 are connected in a circuit in different ways. X is the effective resistance. The properties observed for these different ways of connecting X1, X2 and X3 are given below. Write the way in which they are connected in each case. A. Current I flows through X1, X2 and X3. Series combination. B. X is larger than X1, X2 and X3. Series combination. C. X is smaller than X1, X2 and X3. Parallel combination. D. The potential difference across X1, X2 and X3 is the same. Parallel combination. E. X is equal to X1 plus X2 plus X3. Series combination. F. X is equal to 1 upon X1 plus 1 upon X2 plus 1 upon X3. Parallel combination. Question 9. Solve the following problems. A. The resistance of a 1 meter long nichrome wire is 6 ohm. If we reduce the length of the wire to 17 cm, what will its resistance be? Given initial length L1 is 1 meter, initial resistance R1 is 6 ohm, reduced length L2 is 70 cm means 0.7 meter, and we have to find here resistance of reduced length means R2. As we know, R means resistance, L means length of wire and A means area of cross section of wire. So, resistivity of the wire is equal to R into A upon L. From formula, resistance is equal to resistivity of the wire into L upon A. As the wire is same in both the cases, Therefore, R1 is equal to resistivity into L1 upon A, and R2 is equal to resistivity into L2 upon A. Dividing above two equations, R1 upon R2 is equal to resistivity into L1 upon A. Divide resistivity into L2 upon A. R1 upon R2 is equal to resistivity into L1 upon A into A upon resistivity into L2. Here A will cut and resistivity of wire also cut. Therefore, R1 upon R2 is equal to L1 upon L2. Now, R2 is equal to R1 into L2 upon L1. Now we will put the value 6 into 0.7 upon 1. So R2 is equal to 4.2 ohm. Resistance of the reduced length will be 4.2 ohm. B. When two resistors are connected in series, their effective resistance is 80 ohm. When they are connected in parallel, their effective resistance is 20 ohm. What are the values of the two resistances? Given effective series resistance is 80 ohm and effective parallel resistance is 20 ohm. So we have to find here resistors R1 and R2. Formula: resistance in series is equal to R1 plus R2. Resistance in parallel 1 upon R1 plus 1 upon R2. From our formula, we will keep value here. Resistance in series is 80 is equal to R1 plus R2, and resistance in parallel 1 upon 20 is equal to 1 upon R1 plus 1 upon R2. Now we will do cross multiplication. 1 upon 20 is equal to R2 plus R1 upon R1 into R2. And we know R1 plus R2 is equal to 80. So we will put here the value. 1 upon 20 is equal to 80 upon R1 into R2. Now R1 into R2 is equal to 1600. Therefore, R1 is equal to 1600 upon R2. Now we will put the value. R1 plus R2 is equal to 80, as we know. 1600 upon R2. This is the value of R1 plus R2 upon 1 is equal to 80. So 1600 plus R square 2 is equal to 80 R2. R2 square minus 80 R2 plus 1600. Now we will here put fractions. R2 square minus 40 R2 minus 40 R2 plus 1600. R2 in bracket R2 minus 40 bracket close minus 40 in bracket R2 minus 40. So R2 minus 40 and R2 minus 40, two fractions. Therefore, R2 is equal to 40 ohm. Now this value we will keep in our equation. R1 plus R2 is equal to 80. R1 plus R2's value is 40. So we will keep here 40 is equal to 80. So R1 is equal to 40 ohm. The value of two resistors are 40 ohm and 40 ohm. C. If a charge of 420 C flows through a conducting wire in 5 minutes, what will the value of the current? Given charge is equal to 420 coulomb and time is given 5 minutes, we will convert it into second, that means 300 second, and we have to find out here current. So our formula is I is equal to Q upon T. So we will put here value 420 upon 300. So the current is equal to 1.4 ampere. Current flowing through the conducting wire is 1.4 ampere. So friends, thanks for watching this video.